And what we're showing today is our single stream lathe. And when we say single stream lathe, what we did was we took from what has been built on the mill turn product, and we're carrying it over to the single stream environment. So what I mean is, like when I say single stream, I mean a machine that has a single turret. It's very common going to shops. You see machines that have twin spindles. They are single spindles, but only one turret. So I mean that's what we refer to as a stream. There's just one stream of work happening at a time, and this product lets us really tackle the challenges that you guys run into on this kind of stuff. Things to do with not just creating the tool paths, but planning out the optimal layout of your turret. Help you also to understand, what kinds of jaws you need to use in the chuck, whether that's a 3-jaw or it's a collet chuck. But really, like when you go to running these types of machines, creating the tool paths is the easy part. What becomes a little more involved is determining how to lay it out. So that's what we're going to talk about today. Basically, going to take a part that's pretty typical of what you can run on a single stream machine. Has some live tooling functions on this, and this particular part we're using a twin spindle lathe, but obviously you can do this on a single spindle as well. But like I say, creating the toolpath operations is the easier part. Let me just see a show of hands in the room. How many of you guys work with lathes right now? Okay, yeah, so I see at least more than half the room. So hopefully what we have to show you today will be of some help. So with single stream, the biggest thing that just really helps is that you have simulation with it. And I'm talking about machine simulation. Not just toolpath cutting on the stock, but you can see the tool holding components. In this case, we've got a live tool holder that we're running into the jaws, trying to machine that feature on the part. So, seeing this now just lets us know that, hey, we probably want to use some different jaws or get something that's not hanging out quite as far. I don't know about you guys, but I would rather find out about problems like this now rather than having an actual crash at the machine. These riding wheel drive heads, they're not cheap, so anything we can do to keep them from going bad is a good thing. Another thing that you can do with the visualization is you can take advantage of machines that have y-axis. That y-axis is not only just for live tooling, but you can use that for your static tooling as well. In this case, I've got a tool holding locator that's holding both a finish turning and a rough turning insert, utilizing Capto tooling. We'll talk about 3D lathe tools here in a little while. But machines that have y-axis, it'll surprise you just what all is out there from these manufacturers on what you can pull down. In some machines, you can take advantage of half index. So, if you take a typical lathe like you see in most places, it may have like an 8-station turret, may have a 12-station, whichever the case. But if you get a really involved part that you need to run, you start realizing like, oh man, I need more tools than this machine can hold. So in cases like that, you either have to try to do more with less, or you may have to make multiple operations out of it, just so you can come back with when you can load up different tooling later. If you utilize these types of holders, if your machine is capable of this, you can put a lot of tools on that turret and avoid those kinds of things. And again, this is letting you see it for yourself before you actually go to running. So the next thing we'll talk about, and this is something that we hear a lot from our customers through tech support, is making changes in their post for tool change positions. If you have a pretty small machine, let's take like a Haas ST10, it's small enough that it's okay to let the turret go all the way home in X and Z to change tools. But if you're working on a larger machine, like around here in Texas, you don't really see it so much in Austin, but you see it in Houston. There's some really big CNC lathes in use out there. And it makes no sense to go all the way back home to change tools, but you can't necessarily do tool changes at a set position, like say 10 or 12 inches back, because again, drawing off of my experience with the Houston environment, some of these guys may do some OD turning, but then they're also doing some deep reach internal boring, and they may have a D bite bar that's stretched out. I mean, I've seen some that are like 3 feet. It's crazy. So, obviously if you're going to change that tool, and they usually put it on the opposite side of the turret, you need to back it way off. But if you're doing your turning tools, no need to do all that. But what I'm getting at is in Single Stream, it also lets you utilize the reference point manager. I'll show you where we find this here in a little while, but you can see in this list, it has several predefined positions, park positions for the turret, upper reference returns, but I've added in, you can see these other tool change positions, so you can independently control for this. It gives you more control, basically, is what I'm getting at. So another big thing, and you may already be aware of this, 3D lathe tools. Are any of you guys utilizing the 3D lathe tooling that's available to use in Mastercam? I don't see any hands going up. This you can use in just regular lathe as well, and I'll talk on this, how to accurately represent these 3D models. You'd seen that simulation earlier showing the dual station Capto tool locators, all that stuff. It's a file I put together, and those holders, I actually downloaded them from machiningcloud.com. So we'll talk a little bit about that. And again, when you guys leave here today, if you have just standard lathe, you have 3D lathe tools, you guys can be using this, and I highly encourage you to check it out and put it to work. Again, and forgetting those models, obviously you probably don't want to take the time to have to draw these models out in detail. Maybe if you made a custom holder for some certain thing, yeah, you may want to draw that, but all these things are available to you from these platforms that you can use online. Machiningcloud.com. Have any of you guys heard of that or use it at all? Yeah, machiningcloud.com. You write that down if you like. This is a free app, a free program you can download to your computer, and it's basically an electronic tooling catalog of all kinds of manufacturers. You can pull down models of milling tools, pull models of turning tools like I've done. It's free, and it lets you pull all that down. You can use the models that you get off of this in Mastercam. Sandvik is a little more proprietary in their product, so they have their stuff available directly from them. Sandvik has a product called Coro Plus. By the way, Mastercam has an add-on product called Coro Mill that it automatically links to that, so you don't have to use two different interfaces. You could do this within Mastercam. And then Kennametal, another big player out there, they have a product called Novo. That's another thing you can download for free. But what I'm getting at, though, is you can build these tool assemblies online on these platforms, and then you can download them in and build your tools, and it just makes it a really easy and fun process. You can save it to your tool library for use from then on. I imagine you guys probably have several go-to tools that you use in your shop right now for turning, and it's especially helpful on doing internal work. ID boring, maybe some deep reach, roughing. It's really important to understand the body of that tool to know where you can or can't fit with it, because lathes, they always scared me. A crash on a lathe is always a really scary deal, so anything we can use to avoid that is a good thing. But with that said, we're just going to go ahead and jump into this, show you how this works. We're going to talk about Single Stream Lathe, and what I'm going to start with, I've got a file that's already somewhat began for us. I don't want to bore you guys with the details of all the nuts and bolts of starting off with it. But on this particular example, this one is based around the Haas DS30. That's a pretty popular machine. We see these with a good handful of our customers. A dual spindle Haas lathe that has an upper turret. You can use live tooling on it. do turning work without a y-axis and all that good stuff. Now you notice how this code expert opened up. I'll come back to this here in a little while. For now, we'll just go ahead and minimize that, and we'll take a look at this. So when you're using single stream mill turn, where you'll find that is when you go to your machine type, it's not under the lathe, it's actually under the mill turn button. And when I look in here, I'm just showing just a small sampling of what types of machines we have. This button, by the way, is where you can also access the full level mill turn. Any of you guys, if you have machines like the Mazak Integrex, Okuma Multis, maybe you have a dual turret, NLX machine from DMG Mori, and you want to know how to control for those machines, this mill turn product is built around it. But today we're specifically focusing on single stream mill turn. But what we've done is we've pulled in a Haas DS30 machine, and before we create toolpaths at all, I'll just kind of explain this. When I go to the job setup, you'll notice that this is a little different than what you see in regular Mastercam lathe. It's a little more in depth. Mill turn, when Mastercam put together a mill turn product, they had a unique opportunity to make a workflow as much more specific to these types of machines. And the first thing we've got is what we're using with the left or right spindle. New for Mastercam 2020, you may have noticed that you can now go and edit chuck jaws. They're parametric. You can do pie jaws even if you need to. But it lets you represent the steps that you may put in the vice jaws. Here I can add or release certain steps. I don't know what I would use this for, but basically you tell it what the sizes are. You can tell it what the radius is that it's turned into, whether it's an OD or ID clamp, things like that. When you go to the setup type, on the setup type, this is where you can tell it how we plan on running a specific part file. And right now we're just doing a continuous bar stock, so we're feeding bar stock into the left end of the machine, doing all the work we can in the main spindle, and then we'll use that sub spindle to drive up to the main, pick off the part, we'll part it off, and then the sub retracts home, and then the main spindle already has the next piece of stock pre-pulled. But there might be times that you may just be running a job where you need only that main spindle. So you can select from that drop down piece. You can say that that would be a single piece of stock with no pick off. And when I do that, you'll notice that on the machine configuration tab that it just kind of updates to show you what you have available to you. So depending on what you set up for your setup type, that's what dictates all these settings that you see on the left. The next thing is for part geometry, you have to pick a solid body part. That's one thing I would stress on this, is you have to have a solid body of the part file, not just wireframe. A surface body, that doesn't count either. It has to be a solid body. And ever since Mastercam X9, many years ago, solids has been included, so you all have this ability. Next thing is bar stock. We can tell it what type of bar we're making out of, diameter. If there's an inside diameter involved, we can plug that in as well. And then when it gets time to do the pick off, this is where we can tell it, where will the cutoff be occurring at relative to the end of the part. And when it's all done, it basically sets up the entire process for you. So when you get ready to do that transfer, those transfers are always kind of a tricky deal. This product just makes it a lot easier for you. So let's just go ahead and get started on it. I'm going to hide out all but the turn profile on our main spindle, and we'll just jump into it. So you'll notice that top of my screen, you got turning and milling ops. Makes it really easy to tell where you need to go. For turning, first one I'll do is a facing cut. And I've already got some tools predefined within this part file. I've got some tools set up for the left spindle, some set for the right. We'll just choose this tool on the left. We'll go to our facing parameters. Really nothing different at this point. It's all pretty well the same as you may be accustomed to inside of regular Mastercam lathe. Next thing we'll do is a roughing cut. This rough and cut will give it our profile. Say OK to it when we're done selecting the chain. I'm going to have that cut just kind of extend just slightly beyond the end of the part. So on my lead outs, I always like to tell it to extend that last cut by maybe another 1/8 of an inch, just enough to get a clean overlap. Click OK, and that's what we've got. While we're at it, I'll just go ahead and run the semi-finish on it. We'll go ahead and put the finish pass on it. We'll say the tolerances maybe aren't so tight on this that we can't go ahead and knock that out. And then you think, okay, well, how is this different than standard lathe at this point? I can still go to verify. Launches into our toolpath simulation window, and we can see the just a playthrough of what we can expect. No different than what you guys may be using right now. Problem is, it doesn't really show us the full kinematic. And earlier in that example, you'd seen how that picture is showing the whole machine. So that's what I want to really focus on here, is how to do that kind of thing. Well, before we go to the machine, we have to load those tools onto the turret. And you may have seen these buttons. I don't know if you can see this too well on your end, but in the Operations Manager, you got these 2 buttons at the bottom row towards the right end. They're normally grayed out. Well, when you're in Single Stream Mill Turn, you can use this up, and one of these is set up tools on the machine. So I'll click on that button, and it will bring up our window to let us handle the tool loading. And let me just kind of get this centered up where we can see it. But over here on the right, it shows us our turret, shows us what indexes, what we've got on here so far. And on the upper left window, it just shows us what tools we've got that we're currently using and whether they're loaded or they're not loaded. Right now it says it's not loaded, so I just simply go and drag and drop that onto the index for station number 1. Or actually, it's not letting me put it in yet. So another thing you can do is you can just right click and say load the tool automatically. It puts it over here in the turret, and if you right click on the turret definition, this lets you view how this thing is currently loaded. So right away, maybe this is starting to give you some ideas. You can see how things are positioned on the machine. Whether we can things like right here, we've got a gang holder for our drills, boring bars. Taking basically loading 3 tools into one index. You can see we've got the space out here a little bit further away from the tools that are doing OD turning. And if you have like a deep reach boring bar, you can tell that you may want to put it on the other side of the turret. So when you go to define that tool later, you know what tool numbers you want to be in or around to be where you need to go. Other things you can do on this is you can also go and set projection lengths. So when you make your setup sheet later for the guys using the floor, you can go and tell it, where do you want that tool positioned relative to the end of that locator. And when you're done with that, you can say OK. You can go ahead and check some others, set projection on this one. Just lets us, it just makes it visual. This is the kind of thing that, I don't know about you guys, but when I was on the machine and I would be setting this up, I would set my turning tools and I would index the turret and just kind of see, is this going to clear or do I need to move this? And of course you need to move it. I mean, it is what it is, but it's time consuming. If you want to make that a visual process and not have to deal with trial and error, physically loading and unloading tools, having to indicate them in, things like that. It really goes a long way to alleviating. The next thing, and I know that we're not done programming this part at this point in time, but I'm just going to go and show you anyway. At this point, I want to click the posting button, and it's not actually going to post. What it's doing instead is it's sending this information into Mastercam Sync Manager. You had seen the Code Expert window open up earlier. They have wondered why it did that. Well, this is the Sync Manager. It runs within Code Expert. That's why Mastercam has Code Expert in it. And the way to think of this is just think of of regular Mastercam as your main interface. That's where you're creating the tool paths. You're setting your feeds and speeds, depth of cut. You're just creating the cut motion. You're not so concerned about how it's going to work on the machine just yet. Now we're into the sync manager, and we got here by clicking what is normally the post-processing button. So in the sync manager, this is expanded operation parameters you can use. You can see that here on the left, it shows my operations tree, just like I see in Mastercam, but it has some different items to it. Down at the bottom, it has this timeline that shows you how long it's taken to the machine the part based off of what we've told it so far. I didn't bother setting feeds and speeds or depth of cut, so to me that time looks pretty long, like 3 minutes 51 seconds. I could probably go back and make some changes to that, but I'm not really focused so much on that. I just want to show you more of what you get in here. So, and just to point out, this sync manager is also where if you're on a dual turret machine, you want to know how you create your weight codes. You would see 2 streams over here, and that's where you can do drag and drop of weight codes, and you can sequence the upper turret and the lower turret to run their operations in tandem and make sure it's going to give you what you need. So if you ever wonder how that's done, that happens in here. But right now we're on a single stream machine. That's why we see just one item. At the very top of that tree, you can click that little drop down, and you can give it some different settings in here, and notice that you can plug in for what the job number is and put the programmer name. So if you want to have that automatically drop into your file, that's where you add that in. And then other things like per each operation, like this facing operation, you click the drop down for it. You can tell it what type of coolant you want to be using, whether you want it on before or after it's made to the approach. If you want to use through spindle coolant. And then the reference position, you tell it, where is this tool path going to come down to the part from? And right now it's just coming from an upper tool change position. If you prefer to have it go all the way home, you can just set up a reference position for that guy. So, it makes it a more visual thing. You can plan out where the turret is starting from and where it's going to. In fact, you'll see at the end, when we go to the retract, that's where we tell it where it's retracting to. Other things is on the approach. Like when this tool is making its approach to the main spindle, we've got some options. You can tell it, do we want to do a Z first approach? If you're doing like OD work, or if you're doing ID work, maybe you want to do an X first approach, or if you don't mind it moving diagonally, you can set it to a direct approach. You can go all through this and set these guys up like you see. So at this point, I might want to see, okay, how is this running on the machine at this point in time? So in the top of this window, you see we've got the big G1 button. That's where we'll actually create the code from later. But we've got this simulation button, so we launch that. Now this is using what we selected as our machine within the main Mastercam file. We had selected a Haas DS30Y. So with Mastercam machine environments, these are made by CNC software. It's a simulation of that very machine. So a few more seconds for it to finish loading here. Give you a little tour of the machine simulation interface. Right now I've got the machine housing turned off, but we can turn that on and see the full housing of the machine. So if you want to know if you get machine simulation with this, yes you do. It's a machine simulation of that specific machine. I usually opt to have the machine housing turned off just so I can see a little more clearly into what's going on. But we'll just go ahead and hit play. So you hit the play button, it shows a tool coming in and shows it making the cuts that we've gotten programmed so far. So it just makes it a nice easy visual process. So we'll just go back in here and keep working on this because I want to get to the milling, because the milling is where I think they've really done some great things for us on it. I do know I've got this 5/8 hole to drill right in the center, so we'll go ahead and take care of that. We're going to use lathe drilling. So just like from a turning menu, we choose what type of tool it is we want to use. As for how deep, I'm just going to go in and select the bottom of the hole as our depth. Put a drill tip compensation of 0 just so we can factor for the shoulder of the drill. Click OK, let it generate. And now we've got this hex that we need to cut around the part. So, if you're used to using Mastercam lathe, you've probably noticed how they have the C-axis group of tool paths. Well, when you're in mill turn or single stream mill turn like we are right now, it's actually all been moved just to the milling side. So I'm just going to use a 3/4 end mill to cut these flats, and I'm going to use a radial mounted holder. Just point along X. I'm going to utilize the Y-axis to cut these, and then we'll index the next one and go and go. Well, with this product, I can actually pick all those flats at once. I don't need to concern myself with making tool planes up front. I just simply go and pick these cuts going around the edges. Let's see, we've got one more to hit, and that's it. We'll click the green check. So we're inside the milling operation. Looks no different than standard Mastercam mill at this point. We'll go and pick our end mill. I'm going to go with a 3/4 in this case. So we'll choose that. What's different when you're in single stream mill turn is you've got this new tab called Setup. This is not in standard mill. When you go to Setup tab, this is how you can set up how you're running this live tool operation on this machine. And it automatically kind of knows based off what you're selecting, what it is you're wanting to do, and it was set to Y-axis cross because that's what we want. We want to use Y-axis, make a cut across, and then we'll index the part, make another cut, and so on and so on. Notice there's this little checkbox called Derive from Geometry. It's our tool plane. I think that's so cool. You notice I didn't have to make a tool plane at first before I came in here. I just simply went to clicking Geometry. From the geometry you select, this product can determine the C angle it needs to go to hit it. So just one toolpath, no having to create transforms. It's all done in one. Next things I'll do is I'll just go and make sure that my, maybe I want to use my cutter comp. I'll set it to where. For my lead in and lead out, I just want to do a simple linear move in and a simple linear move back off. No need for an arc on this. Go to linking parameters, make sure my settings are what I like, and then I just click OK. And you notice that it took care of all 6 of those sides. No having to create a tool plane up front. It just knows based off of the geometry. And I just think that makes it so easy. One thing I see is that tool is maybe not quite wide enough to get it in one pass. And, these right angle drive heads, you have to be kind of careful how much you load them up. So maybe we'll just turn on some multi-passes. We'll put 2 multi-passes spaced apart at 3/8 of an inch. Almost messed up to 375 inches. That wouldn't have been good. But anyway, that's all there is to it. And then we've got it to this point. Now we're ready to take care of transferring this part over to the sub-spindle. So just to kind of recount here, I showed you in the job setup how we had gone in and we'd already told it up front where we want that pick off to occur at. So when it's getting ready to transition it over, where we grab it, well, by having done all that work up front, it really makes it easy for us when we get ready to do the transfer. So real quick, I'm just going to regen my ops, get that all nice and take care of. All we're doing is a cutoff with a pick off, utilizing a cutoff to cut it free of the original bar stock. So go to my turning menu, I'll choose to pick off cutoff, and really there's no need to select anything different in here. Wait for this window to come up because it's already preset with what you had already told it in the very beginning. Things that you may want to do though, you may want to just tell it to index the turret around to some position that is going to be clear of having any tooling hanging out, because ideally I'd rather have my turret go all the way home or all the way to the left just to get out of our way, just make it easy to see. So we'll just click the green check and let it go to work, and then the sub-spindle rides up to it, pre-pulls it. It's going to create the cutoff move and back off over here to the left side of the screen, and that's it. That's all done for. You can see that it automatically created this operations group of all the sequencing required to make that pick-off. And if you want to check it out, you can just walk it through, and you just bump your little red arrow to the top of it. You walk it down. You know, that move here was a spindle move. You position the spindle, and you can make edits to this as well. But it positioned the sub-spindle to a 1/2 inch in front of the main spindle. And I don't know, that's pretty close. You know, it may be a little safer. Maybe we'll make it just wrap it at 2 inches in front. Make that change to it. Of course, it reds everything out. But you know, every step of the way, it lets you control it. So you know, just the point is, it makes it easy. So now we've gotten that complete. The next step is to go over here and take care of working on the sub-spindle side. And we do have a little bit of turning work to complete. So I'll just hide out all but that profile. And I will, let's say we'll go with a turning op, doing just a face, or we'll use a facing op on the front of our part here. Oh, first you gotta make sure that red arrow is out of that group. Then it'll let me do it. So now we're going to create a facing op on the sub spindle. What we do this time is at the lower left, you need to tell it what axis combination that you're using. Right? It's by default set to upper left. Well, if we go and say we're going to use our upper right instead, that's just what controls for telling it we're working on that end of the part. Choose our tool to go along with it. We can go and set some other settings, like where we want the finished Z to be. We'll go and click the green check, let it generate. The only thing is, I know this part that has this radius, and I'd rather go ahead and take care of that radius at the same time. So Mastercam facing toolpath, it does have an option for controlling for corner geometry. And so for the corner, I'm just going to go and right click and choose the radius of an arc, because I don't know what that radius is yet. I'll just jump in here and choose it. It returns with the value. Click OK. Just regen it. And there we are. You know, we've got our radius taken care of on the front edge of the part. So we'll go ahead and keep going with this. We have a 5/8 hole to drill on this side as well. So we'll go to our turning ops. Just create another drill op. This time we're going to choose that tool. Make sure you choose the axis combo that goes along with it. Next thing is tell it, how deep is that hole drilled to. Put a little drill tip compensation on it. Click the green check. Let it generate. And it's telling me the tool starts with it embedded in stock, and I think I know what's going on here. So when you're working on the sub-spindle side, when you're in Mastercam, Z being out in front of the part, that actually needs to be a negative Z. Z.1, that's actually putting it into the part by 100 thousandths. Z that we want to start from is coming from the left, so that's negative, so I'll change it to negative 0.1. Same thing for that clearance value, negative 0.25. And something looks odd with this. Let me go and reselect that depth again. 1.5. So let's try this again. Yeah, still having a problem there. So it just kind of goes to show you guys that us guys working here at MLC, we run into things not working for us either at sometimes. So we just have to kind of work our way through it. So let's have a look here. I'm just going to find that real quick, see if we can't get that straightened out. If not, then we'll move on. Oh yeah, that drill point, we need to change that to 0. Because I was originally at an upper left axis combo, was putting a way negative value on that Z. So that, I believe, was our problem. So let's just go and say OK to that, regenerate. Yeah, there we go. Got it. All right. So we got the turning ops done on this side of the part. Now let's talk about the milling. And I'm just a big fan of using Alt-E. How many of you guys use the Alt-E function at all? Alt-E is good because right now, I've just got all kinds of geometry on the screen. But if I'm focusing in on a certain area, just a little tip and trick I like to show. You basically choose what it is you want to have visible. Basically everything else that's not selected will not be visible. And then you simply hit Alt-E on your keyboard, and it hides out everything but that. Hit Alt-E again, it brings it back. Just a really cool way to narrow it down to what it is you want to work on. But we're going to narrow that down to this, and I'm going to focus in on these slots. And I just like to use the dynamic motion toolpath. It's just, especially whenever you have a machine where you may not be able to hold too large of tooling, or let's take the example. Say this part was made out of like some kind of stainless steel. A lot of tool pressure involved. Don't want to overstrain these right angle drive heads. So the dynamic motion really comes in handy on this. So what I'm going to do a dynamic mill, and I'm going to define. I'm going to use face selection by picking only the outer edges. That's going to be my machining area. And I want that tool to work its way in from the front, from the air. So I'm going to define that front edge as an air region. So I'm just going to choose that. And that's it for my geometry selection. So now that we've gotten that, I'm just going to focus on one slot at this time. Go to our tool. Choose, I think that 3/8 end mill will get it. We'll find out here in a moment. May have to go smaller. For the setup tab, again, we're doing a y-axis cross, and we just let it derive from the geometry, the plane that geometry drawn at. That's what will determine the C angle. And if if this has your gears turning, if you're wondering if this works on like an Integrex with a B-axis mill spindle, may have a compound index. This is compound index is made easy. Just choose the geometry. No need to create a tool plane up front. Next steps here is we'll tell it what kind of step over we want. Stock to leave. Maybe I'll leave only 10 thousandths. 50 thousandths is kind of excessive in this case. So I'll come back later with the finished tool path on this. Make sure other settings are good. We just click OK and let it generate. And that's it. So we've got a dynamic mill working its way in on one slot. This case, I will show you how to use the transform on this. And transform, when you're in single stream mill turn, this is also revised. It's freshened up. So what you've got here is the different types of axis combos. In this case, we're using an upper right axis combo. You tell it what type of toolpath is it that you're wanting to transform. I know it's a y-axis cross. And when I do that, it should be showing me what I've got available to use down here. So maybe, I think I see a problem. It thinks it's an upper left, and this is really working on the right side of the part. So that's just telling me I've got ahead of myself. And on that setup tab, I need to be sure and tell it that's an upper right. That's how it knows what work offset you're running on when you're doing this. Real important. So I've got it set to upper right. This should work as we need it now. So we'll do a transform again. It's going to upper right using a y-axis cross, and there's the toolpath we want to use. And what we're doing is just a rotary rotation of it, moving from one side to the next. I know that we've already cut it once, so we just need to cut it 3 more times at an angle of 90 degrees from one to the next. And there it is. It takes care of putting the toolpath all the rest of the way around this part. And just to recap here real quick, is it when you're working a single stream mill turn, you get this setup tab, and this setup tab just makes it so much easier to handle for doing these types of operations. When you're doing milling, you've got more than one option. You can have your end mill pointed straight at the front of the part, or you have it pointed at the OD of the part, or if you're on a sub-spindle machine, it's pointed at that face or that OD. It can get kind of tricky to control for these types of things when you're using these machines and their special abilities. And myself personally, here in the Austin area, I go and visit with our customers, and it's pretty common. I see these types of machines. They've got y-axis, they've got live tooling, and I'll ask them like, "Hey, how do you like using those?" They're like, "Oh, well, we really don't use it." It's like, well, why wouldn't you? It's just, to them, it's a little bit of a mystery on how to program it. And I've always been able to show them how to do it in standard lathe, but this just makes it a much more visual process to get it done. Before I go on to the next subject, though, because I can see all of you here, does anyone have any questions on what I've shown up to this point? No questions? Okay, no problem. Just keep Just keep in mind that if you do have a question at any point in time, just feel free to raise your hand. I can see you on the screen here. Looks like a 70-inch TV. You guys can't see it here, but it's like I'm in front of a real crowd, so I can see you. So let me know. Let's go ahead and move on to another part of this. I want to talk about the 3D lathe tooling, because I remember when I asked you guys if y'all are using that, I didn't see anyone's hands go up. So I'd like to talk about how this works for us. So before I get into the nuts and bolts, I just want to kind of show you guys how this works. Just give you an idea of what's possible. So right now it's opening up the machine for this one. Probably see it come up in Code Expert here in a moment, or actually it's already minimized, so we're good. I'm going to go and show the turret loading on this guy. Go and bring this up real quick, show a preview of it. Yeah, this is the part file that I was using the Capto tooling on. And I'll tell you, Capto tooling, it's great. I mean, I know it's a bit of an investment at first, but man, it just makes setup changes, tooling changes, reconfiguring your turret, just makes it so much faster. It just keeps it modular. Like right here, I've got a locator that's utilizing the y-axis of the machine. Rather than wiping out two indexes on a turret, we just have two tools on one. Have our threading insert on the single station static holder here. Our tools like this, and what I want to demonstrate now is how do you get to this point? Well, I'm just going to start off with a fresh file just with nothing in it. Show you how this is done. So I'm going to hit File, New. There's nothing in here, and for this one, I'll just go to my machine type menu, and I'll just use regular, just standard Mastercam lathe, because I want to point out that you guys can use this with standard lathe. But when I go to my lathe tool manager, say I want to create a tool, and by the way, I can do this from within an operation as well. But when you right-click to create a tool, you'll notice that there's two different tool options. You got Create a Tool, which gives you the standard rectangular type shank tooling that has been Mastercam for many years. But we've also got Create 3D Tool. So when we go to 3D Tool, you're going to notice the interface kind of change here on us. But it all takes place over here on the left side, so it keeps everything visual in the screen when it comes up in a moment. You can tell it what type of tool it is you're defining, whether it's general turning, ID, threading, if it's a boring bar, face grooving, whatever. It's important you define the tool type. You can tell it what tool numbers you want to assign to it, default home position. But then when it comes to defining it, this is where ahead of time I'd already had gone to machiningcloud.com. And I got these tool holder models, got them all put together, and I got them downloaded. And I'll show you real quick. Like when I show in this folder, Machining Cloud, it exports as a zip file. So this zip file is what I pulled down, and then this is just the extracted tool files. I've also got some Mastercam part files in here, but what we're going to do is we're going to start with creating that finish turning tool. So this is the file I got, and it came to me as a step file. So we'll choose that and click Open, and give it a second to open up the file. Waiting on it here. Giving it a moment. Take a sip of coffee. All right. So here's our model. This is the model, the assembly of it, and you want to pay attention to what this little text window is telling you. It says select the insert model. So that's this guy. Now when I do that, it's differentiating now that's only our insert. We can plug in for what the corner radius is. Tell it what type of insert. If you want to give it a more specific name, you can do that. The next step of this, notice how it even replicates the texture of the insert, the edges. It just makes it cool, makes it easier to see what we're doing. But next we have to define a holder. So just like a regular Mastercam lathe tool, same is true in 3D, you have to have an insert and you have to have a holder. So for that, I'm going to go back and select from that step file again, the same one. We'll open that in, and give it a second here to come in. Alright, so from this, we'll just go and select the solid that defines the holder, and you can pick more than one. So let's say you've built up a modular boring bar out of several Capto extensions, and you know, of course you want to replicate all of that, so you can pick more than one solid when it comes to defining your holder. So we've got that done. We'll end that selection. So now we've defined our holder and our insert. Now we need to keep going here, though. We need to tell it down here. I need to tell it, you know, where does this connect to the machine at? And for a Capto holder, it's going to be the back of the flange. And if you're creating a square shank tool, just a regular square shank turning tool, it's always the end of the back end of the bar. So when I get to this point, you know, the next thing is telling it, you know, what is our cutting plane? So the cutting plane, I can't really select it from this one because, you know, this insert has no rake to it, so it's kind of leaned forward. That this plane needs to be parallel with the center axis of the tool, so I don't really have a good face to choose from on this guy, except, you know, I do have this face right here. So I'm going to select a face, choose that. The only thing is, it's not quite coincident with the edge of our insert. So you know, I'm waiting for it to finish determining here, but I can add in for an offset to control for that. So give it a second here to finish selecting. Yeah, there we go. So here's what I mean. You see how it thought that plane is where the insert lies, and obviously that's not where it lies. The insert's way down here. So I can give it an offset. I can go and select, just pick a point on the edge of the insert. So based off that plane it's selected, it'll offset it down to that point. And now we've got a representation that truly coincides with the cutting edge. So, you know, what you can see happening here is Mastercam has taken this 3D lathe tool and it's deriving from it a cross section, just as if you're drawing a custom lathe tool in the past on Mastercam. So at this point, I usually like to put it in the top view so I can understand how this is loaded. Now I know that this tool, it's going to be turning the part on the main spindle, so I'm going to go to this tab, tell it, okay, it is set for left spindle, but here's where it is. It needs to be set for the spindle turning counterclockwise and not clockwise. So when I select that will turn this tool around to point the way I want it. We're getting close to done now, so the next thing I want to tell it is just to make sure it's touched off properly. Yeah, Mastercam by default will go ahead and determine where it thinks you want it touched off, and you can tell it what quadrant that applies to. It already knows the nose race of the insert. You know, these values here, you know, this is things I see commonly skipped when people set up 3D lathe tools, and if you skip this, it really interferes with how Mastercam figures out for approach positions, how to retract, how to factor for plunge cutting. So what I like to do is just go in here and tell it to you know, scan the tool geometry. So it goes in and scans it. It finds all these default values. I'll just check them all on and say to use them. So that fills in the blanks. You don't need to fill in all those values yourself. So that's it. You know, so putting that one together was pretty easy. You know, pretty easy to get it done. Let me show you another scenario that you may run into. And what we're going to do this time is we're going to take care of creating our grooving tool. I know this one is external grooving for our insert. I'm going to go and select a model. And I think this is our guy right here. I'll open that in. Let's see here. Oh yes, look at this. So this one, I wasn't able to get a model that was already assembled. We've got the insert hanging out in space in front of it, so we're going to have to assemble this. So I'll get to that in a minute. Just for now, I need to select what defines my insert. I can tell it what my corner radius is, and then we'll move on to selecting what we want our holder to be. So I basically go and reselect the same step file that I just picked. So give it a moment to import it. This is my holder body in that selection. And now we've got it in here. We'll go ahead and finish picking the machine connection. And like I say, like when you're on a square shank tool, the machine connection is this face right here. Just the opposite end face of it. So when you've got this type of scenario where the tool wasn't assembled, Mastercam has a tool to help you fix this. I actually skipped this tab on the last one because we didn't need it, but it's the tab labeled mating. It's what lets you mate this insert up into the holder as it needs to be. So I'm going to do a coincident mate, and I'm going to select from this other side. I'm going to select this face of the tool, and I want to mate it coincident with that face of the holder. So see, now I'm starting to get somewhere. Next thing is I want to mate, a coincident mate between that face of the holder or the insert and this guy right here. There we go. So now we're almost there. Just now it's just a little too far in to this, and I'll try to do a coincident mate again. We'll say coincident between that face and that face. We'll see if it works. And it wasn't quite what I wanted. That went opposite of what I expected. So sometimes this kind of thing happens, and you want to to fix it, obviously. So we'll go ahead and pick that and mate it back to here. I may want to slide that to alter how it's put in. So you've also got the option to use dynamic transform to edit the location of this. So you just have to pay attention to what it tells you here. You pick a face to position the adjustment gnomon. I'll pick that face at the bottom, and then I'll pick that edge to define the angle I want it angled along. That just presets that X and Y for where it's going to be. So I'm going to switch to a right side view, and I'm going to unshade temporarily. Well, I guess I better go ahead and shade this back again just so we can see, but I'm going to slide this in until it contacts that back edge of, almost, until it contacts the back edge of the insert, or the holder, and I'll hit enter to accept. That gets it into place, and notice it does have an option to stop on contact, so I can slide in just once it feels it, bump it. That's when it knows it's good. So if you ever have to deal with assembling tools that don't come in pre-assembled, that's how you can do it. You can do it with this. Next thing we want to tell is what is our cutting plane? Well, on this tool, that's easy. I'm going to go select just the top of that shank. That's where it clamps up against the spot in the turret. We can look a little closer and see. Yeah, it wouldn't. I guess there's a little bit of an offset here, so no problem. You can just go and select that offset point, pick a point that defines where you want that profile really defined, and that's it. So now we've gotten that. I'll go ahead and switch to my top side view. And I know that this tool is really intended for working on the sub-spindle. And right now it's set as if it's working on the main. Not only that, but it's turning an M4, not an M3 like I prefer. So we'll go to the next tab and we'll tell it, first thing is what spindle is it set for? We're going to be set for the right side. Perfect. That's what I need. That's all I need to do here. So now that I've gotten that, I'll go ahead and control for where's the tool touched off. Now this one, it didn't automatically determine just yet. So sometimes you may have to go and pick for it. No problem. First thing is just pick where, the center of the nose radius of where it will be touched off, and that's going to be right there. And then once you've done that, it's touched to the wrong side of it. So what I'm going to do is I'm going to just toggle, what quadrant is it touched off relative to. So it's quadrant 2. Fix that in. It looks like our nose radius is not. It's a little bigger than what the tool is defined. I think I automatically typed in the value of 8 thousandths. It may be 5 thousandths, so I'll go ahead and set that. Yeah, there we go. That's much better. So now we can go in here and make sure that where it's touched off is right. Still not right. I'll go through and reselect that again. Let's see. We want to go and pick right there. So I guess my nose radius is bigger than 5 thousandths. No problem. You can see it as just a beauty of being able to check it right here within this interface while we're here. So we'll go ahead and check this real quick. Yeah, we'll just call that close enough for now. But I think you guys get the idea. You can go in and set the, pick up all the end clearance and side clearance angles, let it write the values in, and then you click OK, and then you're done. So so how do you guys feel about 3D lathe tools? Anyone going to go back to start trying to create some of these? I don't hear much enthusiasm. I mean, yeah. Come on, guys. This is good stuff. Yeah. So, yeah, check it out. And of course, need help, have questions, just let us know at Mastercam support at mlc-cad.com, or you can call us at our number, extension 3. But I'm gonna go and shift over to the next part of this, which is to do with reference positions. So I'm going to close this. I'm going to go and open up the file that we were just in. Give it a moment here. Yeah, this is what we want. So we'll let this file launch, and it's already pre-done. I've already got toolpaths already done on it. That part's complete. We just want to go ahead and send it straight over to the sync manager. And we'll have a look at what's happening. Let's see if there's areas to improve on this. Let's just say that this is a job that is going to be kind of a high volume. It's a 100-piece or 200-piece order, and let's say it's taking too long. So our job now is to try to figure out ways to speed this up. Well, what I look for on this is how far is it backing off for doing tool changes. Maybe that it's backing off way too far, and all that travel over time, those additional seconds to go back off like that just really starts to add up. So utilizing Mastercam and Mastercam Single Stream with its machine simulation ability, I can check all that out now to find out for sure. So we're just waiting on it to finish opening for me here. Got a lot going on graphically. I've got a go-to meeting. I've got the other computer, or the screen over here on my right. Normally it goes a little more quickly than this, but let this guy open up for us here. So it's almost there. We just want to wait till we see the stock appear in the spindles. Come on. Should be any minute now. There we go. All right. So I'm just going to go and let it start playing. Let's see what we've got happening here. You notice it shows you arrows on the spindle indicating the direction it's turning. Makes it kind of nice. Let's speed this up a tad. So now it's going to switch over to finishing. So it backs off over to here. And like right there, I think, well, I'm just shifting over and using the y-axis to go to the next tool. So really, I didn't need to retract at all. So that gives me an idea. Maybe that's one place I can save some time. And where that's happening is when I look at my operations tree and I go to backplot. It's happening between operation 2 and operation 3. That's when it's going from roughing to finishing. In fact, if I backplot it in here, you notice that the back plot in Mastercam, it can also show that 3D lathe tool as well. So just a nice visual reference for you. So, basically in between those two cuts, I really don't need a retract to happen. So I'm going to go make a new reference position to control that. So it's right next to the tool loading button. It's another one of those buttons that is grayed out in standard lathe, but you click on the edit reference positions, brings up this window, and this is where you can control for that type of thing. And the reference position I want, it doesn't already exist, so I'm just going to right click and create it. I'm going to say, basically call it main, just so I understand it's for the main spindle, no retract. Alright, so now I've got that. You notice that over on the right I can tell it what axis comma does this apply to. It's the upper left. And then for the XYZ axis, I'm just going to leave it at no axis motion at all. Nothing. I mean, now if you wanted to make it something, you can go in and choose from the different options how you want that to occur, but I'm just going to set it to no tool motion. We'll click OK. And now that I've made that change, I need to resend all of this to the Sync Manager. So I'm going to go ahead and do that. Go and resend it back to Sync Manager real quick. And keep in mind, it's just like you're using the normal post-processing button. It's sending over to basically the secondary interface. Because you noticed, maybe you noticed earlier, but when I was going through those operations showing what your options are, reference position that an operation begins from, or it goes to, is in here. So I know what's happening between operations 2 and 3, so I'll expand them open. So on the retract of this, for the reference position it's going to, I'm just going to select from that drop down, and there's that reference position I just made. So main with no retract. Now I need to also remember on the next operation for its approach, you have to tell it where is it coming from, or it's actually this arrow here. So I'm going to make sure I set that it's coming from main with no retract. And that's it. I can go send it back to simulation, or first I want to save it just so it's all in as it needs to be. The little circle turns green, says we're good. But say I just want to post this out at this point. Let's see what we've got going on in our code. I was talking about my can cycles. There's something it doesn't like in my settings. We'll come back to that a little later. But something about my exit length, I need to have at least some value in it. I want to kind of make this a little bigger and easier to see. But I know the first tool is going in and roughing it. It's doing the work on the roughing on the OD, and then here's G53 and there's nothing. That's because we told it to not retract. So that's just going to keep that tool right there. It's going to move over in Y and go right back to working. So things like this you can really start trimming out a lot of excessive runtime. And so that there's some other reference positions that I made in here. Just kind of talk about these here. Well, that was my tool loading button. That was not the right button. Let me close out. I'm going to try to close it. Click my green check down here. There we go. So in the reference position manager, I talked earlier on it, but the ones that you see that are gray, those are just those are system reference points for you. Those ones can't be changed. But these other ones, like I did a main spindle no retract earlier. Another one I'm doing like for like a closed tool change on the main. I just went in and I set a position, and remember this is relative to home positions. That's why you see a Z -5 in there and an X -1.2. This is where I'm controlling just to have it move it not too far away when it's getting ready to do these types of things. And it just really makes it easier because of course you can do this in standard lathe, but you're just plugging in an X and a Z value. This one you can do this. You can set more than one, and then in the end you can see the visual result of it when you go to your simulation. So that's what I'll do real quick. I'll go over here to our sync manager. Now right there, you notice that the simulation button is grayed out, and my window actually has a lock symbol on it. What that's telling me is it knows I just made some kind of a change over here, and realistically I didn't, but it knows I did something, so it needs this to be resynchronized with the Mastercam file. So I basically just resend it to the sync manager. And once it's back in there, then I'll be able to run a simulation on it. Does anyone have any questions so far on this? Do you have anything to add, John or Brian or?
Great, yeah.
Okay, good deal, good deal.
I think they're still awake.
Yeah.
Yeah. Notice when we're done.
Yeah, well, this screen over here, it's a big screen, so I can see pretty well. I don't see anyone asleep yet. Now, there's a guy in the back left corner of the room. I can't see him, but I trust he's awake. So. But yeah, it's just to talk a little bit about while this is starting up, just talk a little bit about like what I've experiences I've had is like when you're working on a mill, when you crash a mill, like a 3-axis mill, usually it's not much worse than you break an end mill off, or you run a drill bit into you didn't retract high enough and you wrap it over a clamp or something like that. The tool is always usually the weak point. But man, when you're on a lathe, everything's just super rigid. There's a lot of rotating mass. We always call those the spectacular crash machine. That was before we started using Mastercam, though. This one we had to program it by hand. And I'm glad I learned to do it that way, but I'm sure glad we've got Mastercam. Yes, we're just waiting on this simulation to finish loading up its stock, and we'll get this started up.
In the mill turn environment, right? We all know that this is just lathe, but you got to add a separate environment, if you will. Environment means simulation plus the post, and they're working together. So that's a separate charge. So that's kind of how this works.
Yeah, and from a tech support side, it actually makes it a lot easier because you all are aware of like with a post processor for a given machine. You usually have 3 or 4 files. You've got the MMD file or the LMD. You've got the control file and the post processor, and it's important they all go in the right place. With Single Stream Mill Turn, it's a single file. It's a dot machine. It's all contained in one deal for you. So go and let this play. Rotate where we can see here. What I'm wanting to see is if the that retract, like right after that cut, I should see it not retract at all. So right here, it should be switching over to the next tool. Yeah, perfect. That's what I was looking for. So just this. I mean, like what I've done. I've had some projects I've done for MLC for customers of MLC where we've used this product, and I'll tell you, like creating the tool paths, like I say, that's pretty easy. It's straightforward. It's not a lot involved with that. Have to spend some time, specking out tools, getting the models, setting feeds and speeds, depth of cut, per what the manufacturer recommends for a given material. But I tell you, like where it gets time consuming is right here. Watching it play through. Just setting an optimal process. Designing this to run. In the most efficient manner possible. By not having a simulation, you're just really relying on what you get to the machine and see, and it turns into trial and error. You'll see something improve, you'll repost, you'll try it again. Eventually get to the point you want to be. With this product, you can get all that done in the very beginning. Really, you can save a lot of time on that. Something I want to show you real quick is, I talked about how you can go to the different sites like Machining Cloud or Novo or Sandvik's Cora Plus. But as long as you're current on your Mastercam maintenance, the Mastercam.com has a really nice tool or set of tools available to you. And I'm just going to go to it real quick. I'm going to log into Mastercam.com with my login, but what you'll see on mine is the same as what you'll see on yours. I thought I told it. Finish login. Refresh that. Okay, so now that we're in here, if you go to that Communities tab, there's a thing called a Tech Exchange. And like I say, I mean, you have to be current on your Mastercam maintenance to see this. But when you go in here, I mean, there's all kinds of goodies you can download. It has pre-set search tags in mind, but you can tell it here. Basically, you want to search for post processors. There's all kinds of post processors to pull from in here. You can switch over to tool libraries, and in this, you can see all the different tool libraries that are available to download. I've got MCO line of cutting tools. Mitsubishi Circle Segment, that's for the accelerated finishing abilities of Mastercam. But you've also got the ability to pull in locators. So if you're like on a given single stream machine, or you're looking for certain types of holder, like right here we got a Kuma BMT60 locators. That's for their BMT60 turret. Here's for our DMG Mori utilizing VDI. DMG Mori tool locators. There's all kinds of stuff you can pull down from this directly to your Mastercam file, to your library that you can use from then on. Because one thing you may notice if you start using single stream mill turn, it already has several predefined shank locator holders. But if you want to get into using Captos, Capto style holders, whether it's static or if it's live, it's surprising what you can find in here that has to do with those. Like right here, we've got our Sandvik locators for Mazak machines. Just makes it more quickly and easily able to be loaded in. All your reference points or the tool locating points are predefined. It just makes it fall into place really, really easy for you. Let's go back into Mastercam and see where we're at in the simulation of it so far. Now I think it showed while I was on the other window, but there's actually a collision that happens in this file. There's a collision that happens whenever we're doing a part off on the main. This grooving tool over here on this side was crashing with the sub-spindle, and so obviously that's not going to work. So I look at this and think, well, where else can I put that part off tool? Not only that, but I'd rather have it kind of offset more towards the right rather than the left. So look around this turret, and I don't want to put too close to that long drill. That might be bad. But it looks like that's the only spot I've got. Maybe I'll try tool 10. Put it in spot number 10. So we go back into Mastercam, and I go to that tool loading, and right now I know that cutoff tool. Right now it's currently sitting in tool 5. So what I would do is just from a turret over here in tool 5, I would right click and remove that tool out of there. And I need to change the tool number so it goes in tool 10, so I can simply edit the tool from this side. Tell it we want it to be tool 10 in this case. Click OK to that. And then I want to find a locator that I want to use for it. So that's the bottom left of this. These are all the available locators I've got to choose from. And what I want to do is I want to use a cross turning that's set for a right insert down orientation. So I think that's going to be this guy right here. It's 20mm cross turn. I'm going to drag and drop it over here to station 10. And then I'll drag and drop the cutoff tool on top of it. I'll go and view the component and everything put together. It looks good. If I wanted to adjust to projection, I could do that, but that actually looks about the way I would rather have it sit. So we'll stay with that. We'll go ahead and preview the entire turret. Something something I'll show you about this is, once you've got that turret up on the screen, it may be kind of handy to print off an image of that for your setup sheet later. Or if you want to just do a print to PDF, wherever you prefer. But let's say you want to put it into a setup sheet. Let this finish coming up real quick. Yeah, so once it comes up, you can actually take pictures of this to save to put on your setup sheet. And where you find that is on that view tab, or actually machine tab. On the setup sheet, you can do an image capture and just have it capture an image of the turret like it is right there. You may want to zoom in close on a certain area just so the operator understands a little better. Say we'll take a pic of that. Go around to, say, like this station here. I mean, you can just keep going, however long you want to do it. And then when you make your setup sheet later, these images can populate out to that sheet. And if your setup sheet doesn't do that, you have no fear. That's another service that we offer here at MLC, is creating setup sheets, custom to specific customers. I've actually got a customer over here in the Austin area that I finished making one where it just, we basically just took an example they gave us. They've been making them in Excel, and we just took that and mimicked it, so it doesn't confuse their guys when they get this new setup sheet format. It looks totally different. It looks just like they've been accustomed to. That's the service that we offer, being able to do that kind of thing. So if you guys have any questions on that, be sure and ask John about it, or talk to Brian. If you got any specific things you'd like to solve on it. But that being said, that carries me to the end of what I have to show for my presentation materials. So at this point, I wanted to open it up for Q&A. I mean, does anyone have any questions on anything, or anything you'd like to see in a little more detail?